Hello everyone. I'm going to talk about redox reactions. In this chapter, we are going to review all types of chemical reactions by a new definition. In chemistry, we have 5 types of reactions in traditional or classical format: synthesis or combination, decomposition, single and double displacement reactions, as well as combustion reactions. But in this chapter, we are going to review all types of reactions by only one type of reaction. We call it redox reaction. We are going to define redox reaction and see how it works to define the different types of reactions in the chemistry. This is, this is the latest model or latest type of reactions we need to know in the chemistry in higher level. Redox reactions stands on reduction-oxidation reaction. So RED represents reduction and OX represents oxidation. It looks we have 2 parts for the reactions, and we are going to work on the definition here right now. First, I'm going to ask you to pay attention. In this chapter, we are going to define a new type of reaction. I'm going to express that one because we are going to work on electrons instead of elements. In combination reaction, in single displacement, double displacement, combustion, we always talk about the elements, atoms, compounds. So if we have the reaction between element and compound, we call that single displacement reaction. If we have one product, we call it combination reaction. If we have one reactant, one formula, one compound, we call that decomposition. So we talk about something like that. Here in this chapter, we are going to talk about only electrons, electron exchange between 2 different atoms. So here we have the basic definition. I may ask you to learn that one. This is the first assumption and definition for this chapter. As you see here in this cartoon, I am going to help you to memorize the definition. If you look at the other resources, you will find a different cartoon or different help to memorize these definitions. Here, I'm going to say that losing electron means oxidation, and here gaining electron means reduction. So we are talking about these 2 definitions: losing electron, gaining electron. As you see here, we are going to have one atom loses electron and one atom gains electron. If we have these 2 processes happens in the same time, we call that oxidation reduction reaction. Losing electron, we call that oxidation. Gaining electron, we call that reduction. The atoms lose electrons, we call them they are oxidized, and the atoms gain electrons, we call them they are reduced. So if you memorize this definition, it helps, these 2 definitions, it helps you to answer the question in this chapter. Atoms gain electrons, they are reduced, and atoms lose electrons, we call them they are oxidized. If you remember earlier, when we work on the periodic table, I talked about 2 types of elements, metals, nonmetals. And when we reviewed properties of elements characteristics, I said metals lose electrons and make positive ion, make cation. Metals lose electrons. And nonmetals gain electrons, make negative ions, anions. Nonmetals gain electrons. So if we look at this definition here, when we say atoms that lose electrons, so it means we talk about metals. Metals lose electrons and being oxidized. Atoms gain electrons. So nonmetals gain electrons, and reduce. So it looks we may have a reaction between metal and non-metals. At this time, we have losing electrons by metals and gaining electrons by non-metals. Look at this example. In this example, we have sodium as one metal reacts with chlorine as non-metal molecule. So this reaction, metal reacts with non-metal, we call that redox reaction, because during this reaction, metals is losing electron, but we cannot see, a non-metal gaining electron, and we can see. If we are going to work with the definition and work on this definition in the reaction, we may write something like that. Sodium lose electrons. Whenever we lose electron, we make positive. Sodium lose electron, it makes positive ion. So losing electron and making positive ion. Cl2 gaining electron and make an ion. Since this reaction should be balanced, 2Na, so I am going to write 2Na here, 2Na here, so 2 electrons here. As you see here, 2 electrons lost by sodium, 2 electrons are gained by chlorine. Losing electron, we call it oxidation. Gaining electron, we call that reduction. Always we need to have these two as a pair reaction. So sometimes we call that semi-reaction. These two should happen in the same time. Simultaneously, we need to have this redox reaction. The reason, because we need to have resource of electrons. This resource of electrons can be produced by metals, and non-metals can gain these electrons. So metal, non-metals. As you see here, atoms or elements lose electrons. We call them oxidized. They are oxidized. And the elements, they are gaining electrons. We call them they reduce. So if I'm going to talk about these two here, I'm going to say metal is going to participate in oxidation reaction, is oxidized, and Cl2 as a nonmetal is going to gain electrons, it's going to be reduced. In the next slide, I'm going to explain by more details. Again, oxidation and reduction must happen in the same time because we are going to exchange number of electrons. Right now, I may ask you to pay attention in these two definitions, and I'm going to work on one example for this one. As you see here, always for the reactants, like the example I wrote on the previous example, we have like this. Let me balance that. So metal, non-metal. Metals lose electrons, so they attend in the oxidation reaction. We call them they oxidized. And non-metals lose electrons, they attend to reduction reaction, so we call them they are reduced. It says the reactant that reduces an element in another reactant is called the reducing agent. So this element, sodium, causes another reactant reduced. It causes another reactant reduced. We call that reducing agent. Right now, let me clean it up. We should have Na. Right now, I'm going to work on this. Please read this definition. We say if we have a reactant is reduced, we call it oxidizing agent. Why do we call that oxidizing agent? Because this element causes another reactant oxidize. Another reactant oxidize. So we call that oxidizing agent. We talk about only reactants. We talk about only reactants. Please pay attention. We don't work with the products, only reactants. So always when we say redox reaction, one element is oxidized. We call that reducing agent, and another one reduced, oops, sorry, we call that oxidizing agent. So these two definitions can be used in our chemistry class. Oxidize means reducing agent, and reduced means oxidizing agent. I may ask you to remember our definition we use in our class. Losing electron means oxidation, oxidized. So after that, you can change to reducing agent. And gaining electron means reduction, means electron uh, gained by element reduced, and we call that oxidizing agent. So let me clean it up here, and you can see everything by the slide. So sodium is oxidized, Cl or Cl2 is reduced. So Na is reducing agent, oxidized, we change that one to reducing agent, and Cl2 is reduced, we call that oxidizing. Right now, I may ask you to work on, I will back to this slide. I may ask you to work on these two examples, first two examples, and say which one is reducing agent, which one is oxidizing agent, which one is reduced, which one is oxidized. Work on the definition. I may ask you pause the video and work on this. Right now, I'm going to work on the first example. MgO2 MgO. Metal, non-metal, so metal losing electrons, oxidized, non-metal gaining electron, reduced. When we say metal is oxidized, like Mg here, we call that reducing agent, and when it's reduced, we call that oxidizing agent. Another example, Fe plus Cl2, metal, non-metal. Metals lose electrons, oxidized. We call that reducing agent as well. Non-metal gains electron, reduced. We call them oxidizing agent as well. As you see here, we may have like this. Again, I may ask you to memorize the definition at the beginning we have, but we don't work with something new. You know, metals lose electron and non-metals gain electrons. How about this example? Right now we have two non-metals. We have two non-metals. Whenever you have two non-metals, or whenever you have two, sorry, we have two metals here. Whenever you have two metals or two non-metals, we need to know which one is stronger, which one is stronger, which one is weaker. So we, in our class, we work on activity series of metals. If you remember that, we work on one table like this one. At that time, I told you we have some elements here. They are more active, so they are a stronger one. And whenever we are going to work on the non-metals, we may have some table like this one. So as you see here, we can see the activity of elements, or as you see this statement here, a strongest tendency to lose electrons, or more active elements, or something like that. So lithium on the top is most reactive metal. It means it's going to lose electrons, and gold here is least active. It doesn't tend to lose electrons. So based on this table, you can find out which element is going to lose, which element is not going to lose. It doesn't tend to lose. Look at this one, zinc and Fe. Zinc and Fe. We are going to see how it works. Zinc is here and Fe is here. Zinc, Fe. So as you remember that in our class, for the single displacement reaction, I said we do have this reaction because zinc has higher activity than Fe, and we can have this reaction. When zinc has higher activity, it means it tends to lose electron. Losing electron means metals, and it doesn't tend to lose electrons. So in this scenario, we say it acts like nonmetal. It's not nonmetal, but it may act like a weaker metal. So metal means oxidized. Not metal, we may call that reduced. Again, it's not nonmetal. It acts whenever we are going to compare zinc and Fe, it acts like a nonmetal. So back here, so zinc is oxidized, Fe is reduced. Zinc is oxidized, it means reducing agent, and Fe is going to be reduced, so we call that oxidizing agent. So if you have both metals, we may have help based on this table. Also, we do have that one for non-metals if we are going to work on this chapter by details. It's not the one part of our class. But as you see here, this definition is a little bit confusing. It's going to be clear if we work on some examples. But we are going to work on a new definition for some problems we are going to solve. We are going to work with a better short wave method. Right now, I'm going to ask you, think about the first bullet. For the reactions that are not metal and non-metal, or do not involve oxygen. So when we say oxygen, it means we are going to have oxidizing, like this example, we are going to have oxidizing agent. So this is the basic definition we may have for uh, this reaction. But assume that we do not have like this one, like the last example, zinc and Fe2 positive. So right now we are going to work on a new method. This method, we call that oxidation number method. We are going to work on oxidation state or oxidation number. Your textbook prefer to call that oxidation states because we don't have a real number in the chemistry. We call that oxidation number. This is an imaginary number. So it doesn't exist like the ion charge number. In a 1 positive, it means sodium loses 1 electron. So this is the ion charge number. But whenever we are going to talk about oxidation number, this is the only explanation for one method we are going to apply. So please understand we are going to work on a model, and the oxidation states or oxidation number, they don't exist. We need to know some rules. We need to know some rules. First, you just need to know that we may have some exceptions. We may need to follow the rules in order. First, I'm going to work on this one. Elements, free elements, have oxidation number 0. What does that mean, free elements? If I say Na, this is a sodium element. we say oxidation number for this one is 0. If I say, for example, magnesium element, oxidation number is 0. Non-metals, if I say Cl2, we know that chlorine exists in diatomic molecule. Oxidation number is 0. He, helium, oxidation number is 0. So elements in the periodic table, oxidation numbers are 0. If we have monoatomic ions, oxidation number equal to their charge. What does that mean? If I ask you what is the oxidation number of sodium 1 positive? So sodium 1 positive oxidation number, it's same as charge. So I say 1 positive. What about oxygen 2 negative? Charge is 2 negative. Oxidation number 2 negative. So again, if we have element is going to be 0. If we have ion, it's going to be same as charge number. One thing I may ask you, you can combine these two rules and say, what is the charge for this? None, 0. You should say 0. What is the charge for this one? What is the charge for that one? 0, 0. So it would be like this. What is the oxidation number for N3 negative? Nitrite. So we say 3 negative. What is the charge for nitrogen? Here is element, diatomic molecule, 0, no charge. So there are something I may ask you to pay attention for these rules. So let me work on another rule. This is the most important rule in this slide. Rule number 3, as you see here, we may have probably more than one part, 2 parts. So it says, if we are going to calculate oxidation number of element in the compounds, so we should consider that the summation of the oxidation state must be equal to 0. What does that mean? NaCl, I have this one. I know that when we say NaCl, we are talking about ionic compound, Na1 positive, Cl1 negative. I'm sure you remember that one. NaCl as an ionic compound composed of 2 ions, cation, anion, positive ion, negative ion. So it's composed of Na positive and Cl1 negative. Right now, what is the charge for Na1 positive? +1. What is the charge for Cl1 negative? 1 negative. Oxidation number is 1 positive. Oxidation number is 1 negative. Summation of these two, it says sum of the oxidation states of all atoms in the compound is 0. If you add these, add up them, total is 0. So always when we have compounds, the oxidation number between elements have this relationship. If you add them, you will see numbers are going to be 0. Look at the next one. If we have like this one, summation of oxidation states of polyatomic ion is equal to charge of ion. For example, in this example, NO3 1 negative. I'm going to know what should I write. I say oxidation number of nitrogen plus, we have 3 oxygen, times oxidation number of oxygen. If we add them, it should be equal to 1 negative. So oxidation number of nitrogen, if I know that, oxidation number of oxygen, if I know that, because we have 3 oxygen, we multiply by 2. So summation is going to be same as charge, 1 negative. Look at this example I gave it you earlier, NaCl. Oxidation number of Na plus oxidation number of Cl. when we say Na, let me write Na positive, Cl, let me write Cl negative, because they are metal, non-metals. Anion, cation, and ions. It should be equal to charge. Charge for this compound is 0, so you should write 0. But charge for this ion is -1, so we write this. We cannot write charge for N and O because this is the ion. Non-metal, non-metal. You cannot say positive, negative. So you cannot write anything. You should write oxidation number of nitrogen, oxidation number of oxygen is equal to, the summation is equal to -1. Here is difference, metal, non-metal. Right now, one possible question, how to find these numbers. I'm going to explain for you later. Guys, we are going to make simplest rules. Group 1 elements. Group 1 elements. They have oxidation number positive 1. If you say NaCl, write that oxidation number for Na1 positive because Na group number 1. So if we have, for example, this compound, NaNO3, so Na group 1, please write 1 positive. We are going to work on this step by step. Group 1 element, please write 1 positive. How about group number 2? Group number 2, 2 positive. So if I have like this example, MgCl2, so magnesium group number 2, please write 2 positive. Right now, how about this? CaO, calcium group number 2, 2 positive. If I ask you, what is the oxidation number of oxygen? So you should be able to answer. Because you may say oxidation number of calcium is 2 positive. So I'm going to write that. What is the oxidation number of oxygen? So let me solve that one. CaO. So you should say 2 positive plus oxidation number of oxygen we are looking for is going to be, what is the charge for this compound? Nothing, 0. So based on the previous rule, the summation of the oxidation states, oxidation number of elements in the compound must be 0. Please look at this summation of oxidation states of all the atoms in the compound is 0. So if you solve that, you may say oxygen is 2 negative. We knew that because CaO is ionic compound. Calcium group number 2, oxygen group number 6, 2 negative. We knew that. How about NaCl? So let me say NaCl. What is the oxidation number of Cl? You may say Na group number 1, 1 positive, plus Cl, we are going to know what is the oxidation number of Cl, is going to be, what is the charge for this compound? 0, 0. So whenever you solve that, you may say it's going to be 1 negative. So Cl is 1 negative. How about MgCl2? How about MgCl2? So based on the rule, magnesium is 2 positive. So I'm going to write it 2 positive. Plus, I have 2 chlorine. I say 2 chlorine. What is the charge for this compound? Nothing, 0. So I am going to solve that one. If you solve this, you are going to get charge for chlorine is 1 negative. Oxidation number of chlorine is 2 negative. So you need to only pay attention how to plug in the equation and solve your problem. And the rules are going to continue. Oxidation number. Look, You don't need to calculate. Please pay attention. Only one thing I may ask you. Non-metals higher on the table take priority. What does that mean? So if we have the fluorine, one negative, hydrogen, one positive, oxygen, two negative, and so on. Group number one, group number six, group number seven. So they are something you should know as major nonmetals we have in our compounds. Group number seven, one negative, six, two negative, five, three negative. So guys, it means most likely we have oxidation number like charge number. Group number seven, what is the charge for them? One negative. Group number six, two negative. Group number five, three negative. But this is not always. It depends on the compounds. I may ask you to only work on the definitions that we have in our class. So I'm going to ask you, pause the video and answer the question. What is the charge, or sorry, what is the oxidation number or oxidation state of each element? Each element. Br2, so this is the molecule, it's going to be 0. So as you see here, you will see like this, 0, rule 1. Potassium ion, it's going to be monoatomic ion. So you are going to say 1 positive. LIF, I don't know what is the charge for Li, what is the charge for F? Li group 1, 1 positive. F, I ask you to memorize that, 1 negative. CO2, right now we are going to know what is the charge for C, what is the oxidation number for CO2. What is your answer? Would you like to take a look at this slide again? No information for group number 4. What should we do? We know that oxygen is 2 negative. We know that oxygen is 2 negative. So carbon plus. We have 2 oxygen. Each oxygen is 2 negative. What is the charge for this? It's nothing. 0. So carbon is going to be 4 positive. So whenever we are going to know that oxygen, 2 negative, we are going to know what is the carbon. And we are going to solve like this one. Let me erase that one, and you will see the answer here. So rule 3a, it means you need to calculate. How about this one? SO4. Again, we know the oxidation number. So we need to calculate for S. S plus. We have 4 oxygen. What is the oxidation number for oxygen? 2 negative is equal to. What is the charge here? 2 negative. So the summation should be same as this one. So I'm going to solve that one for the students. They don't have any idea how to work with this. We add plus 8 to both sides. So we are going to have 6 positive. Let me write like this. The reason I intentionally write like this one because I'm going to make sure you find the meaning of charge of compounds and ions as well. So we are going to have 6 positive. And lastly, we have like this one, Na2O2. So Na group 1, let me calculate for oxygen. Na group 1, 2 positive. 2 times 1 positive. Group 1, 1 positive because we have 2 in Na multiplied by 2. Plus, we have 2 oxygen atom. 2 oxygen is going to be, what is the charge? It's 0. So 2 plus 2 oxygen is going to be 0. I have to add negative to both sides, this one and that one Cancel out 2 oxygen is negative 2. Divide by 2. So it looks oxygen is 1 negative. Guys, this is the exception. We call this one sodium peroxide. Peroxide. If you remember, when we work on the polyatomic ions, peroxide has like this formula. I'm going to ask you to let me know what is the oxidation number for oxygen here. I have 2 oxygen. It's going to be 2 negative. Monoatomic ion, for example. So oxygen is 2 negative divided by 2, 1 negative. So for peroxide, this is not oxygen. For peroxide, we have 1 negative. We have 1 negative. So that is why I told you we have some exceptions and we need to pay attention for our exceptions in this chapter. But to simplify that one for you in this level, I'm going to ask you to memorize oxidation number of these two, hydrogen and oxygen. Hydrogen is +1 and oxygen is -2 in compounds and ions. Please pay attention. Oxidation number of hydrogen and oxygen in compounds and ions is like this. If you memorize this, you are able to answer more than 90% of the question in this chapter. Let's see what does that mean. I'm going to work on oxidation number of sulfur in this compound, H2S. So you should say we have 2 hydrogen, each hydrogen +1 plus. We have 1 sulfur. Charge is 0. There is no charge for this compound. So sulfur is negative. How about this one? If we have H2SO4, I'm going to ask you what is the oxidation number of sulfur. So you should say we have 2 hydrogen multiplied by 1 positive plus sulfur plus we have 4 oxygen. Charge, oxidation number of oxygen is -2. Is equal to charge. There is no charge for this compound. It's 0. So I'm going to show that 2 plus S plus -8 is going to be 0. 2 plus -8 is -6 plus S is going to be 0. S is going to be +6. Oxidation number of elements, it depends on their compound is going to be varied. So we cannot say S always is -2 or +6. It depends on the element. It depends on the compounds. So we are going to have different oxidation number. So here S has -2, here is +6. How about this one? SO3 2 negative. I'm going to know what is the oxidation number of S. So I say S plus 3 oxygen. Oxygen is -2 because oxidation number for oxygen in ion is -2. It's going to be same as charge. Charge is 2 negative. So S plus -6 is going to -2. So S, we are going to add +6 to both sides. This one and that one. So we are going to have +4. Again, is going to be different number we already calculated. So how about this one? This last example here. I'm going to know what is the oxidation number of sulfur in this compound. So we should say 2 sulfur plus 6 oxygen. Each oxygen is -2 is equal to 0. 2 sulfur plus -12 is going to be 0. You should add plus 12 to both sides. So 2s is equal to 12 divided by 2. So we are going to have 6. S is plus 6. It's going to be like this. I may ask you to work on some examples like this one for any compound. For example, you may say HNO3. What is the oxidation number of nitrogen? You have H, you have O, so you may plug in here. And after that, you may, if you work on this, you may get N plus 5. And finally, I may ask you to work on this. Find oxidation number of nitrogen in these compounds or ions. Nitrogen is free element, 0. Nitrogen here, N plus. Oxygen group number, 2 oxygen. Oxidation number of oxygen is 2 negative, is equal to charge. Charge is 1 negative. So N plus 4 negative is equal to 1 negative. We add 4 positive to both sides. I'm gonna make sure you understand how to solve the problem. That is why I review the strategy to get that. And I'm going to calculate an oxidation number. Sodium group 1 plus nitrogen plus 3 oxygen. Oxygen is 2 negative. What is the charge for this compound? No charge, 0. So plus 1 plus nitrogen plus -6 is going to be 0. This one -5 plus nitrogen is going to be 0. So nitrogen is plus 5. So one oxidation number is 0. One oxidation number plus 3. One oxidation number is plus 5. So you need to know how to calculate. Right now, I'm going to combine this information whenever we are going to work on the reactions. If you remember, I told you we are going to work on a better definition and better method to find out what element, what reactant is oxidized, reduced, oxidizing agent, reducing agent. Please look at these two definitions. If oxidation number increases, we call that oxidation. If oxidation number decreases, we call that reduction. Please look at these two definitions. We talk about oxidation number. So one reaction is oxidation, one reaction is reduction. So we are going to work on these two reactions based on oxidation number. Right now, we are going to work on this example. Assume that we have this reaction. I'm going to show you how it works. First, before working on this, I told you if we have oxygen in the reaction, this is the meaning of classic or traditional definition of oxidation reactions. Please look at this slide. I told you if you have oxygen as one of the reactants, we call that oxidizing agent is reduced. So we are going to see Can we have the same conclusion for this one or not? Right now, we are going to say that we want to find the oxidation number of any elements, any atoms here. So hydrogen in the compound is +1. So if I am going to know what is the oxidation number of carbon in CH4, I am going to say carbon plus. For hydrogen, hydrogen is 1 positive. I ask you to memorize for hydrogen is 1 positive in the compound is equal to charge 0. So if you solve that, C is -4. So I write 4 negative here. So I find oxidation number of carbon. I know that for hydrogen. Oxidation number of oxygen, O2 molecule, 0, free element. For CO2, I'm going to know that we know for oxygen. So let me write it here. CO2. I'm going to find for carbon. C plus 2 times 2 negative, charge is 0. So C is -4. So, sorry, it's +4. C is +4. So we calculated that. This is for carbon, this is for oxygen. H2O, in the compound, hydrogen is 1 positive, oxygen is 2 negative. So we have all of them. Right now, we are going to compare oxidation number of same elements. Carbon, please look, oxidation number of carbon here is -4, on the right side is positive. Oxidation number increases. When oxidation number increases from -4 to +4, oxidation number increases, we call that oxidation reaction. Oxidation reaction. So this element is going to lose electrons. So we are going to find what reactance is going to be reduced. Look here, oxygen is 0. So it's going to change to 2 negative. It doesn't matter because we have 2 negative here, 2 negative here. There is no difference. So you may compare 0 with one of these two. I'm going to compare with these 2 negative. Oxidation number decreases. It's reduced. So we call that reduction reaction. So always we are going to compare oxidation number of elements and see which one is reduced, which one is oxidized, which one is going to make oxidation reaction, reducing reaction. In this reaction, we could find CH4 make oxidation reaction. So CH4 is oxidized. Do you remember that we used another term for oxidize? We call that reducing agent. So we say CH4 is reducing agent. We talk about compound. We don't talk about element because the element belongs to this compound. O2, as you see here, it's going to participate in the reduction reaction. Reduction reaction means reduction. We call it reduced. Do you remember what we call that reduced? Oxidizing agent. So always, again, we look at the reactants. We don't talk about products. Reducing agent, oxidizing agent. Reduced, oxidized. Everything here on the left side, in the reactant side. Right now, we are going to work on some examples. N2 plus H2, we are going to make NH3. This is the combination reaction, if you remember that. We are going to define that based on the redox reaction. based on the redox reaction. Let's see how it works. Oxidation number of nitrogen is 0. Oxidation number of hydrogen is 0 because they are free elements. How about this? I know hydrogen always is +1 when we have a compound. I need to find oxidation number of NH nitrogen in NH3. N plus 3 hydrogen group 1 positive charge. What is the total charge for this? 0. So N is going to be 3 negative. So I write it 3 negative. We don't look at the coefficients. Coefficients talk about the number of atoms. We only focus on the oxidation number. Right now, nitrogen is just changed from 0 to 1 negative. Hydrogen just changed from 0 to 1 positive. Look at the nitrogen. 0 to 3 negative. Reduced. Decreased. We call that reduction. Hydrogen oxidation number increases. We call that oxidation. Right now, I'm going to talk about the reactants. Nitrogen is going to make reduction reaction. Reduction reaction. Reduction means this compound reduced. We call that oxidizing agent. H2, this reactant, is going to participate in the oxidation reaction. So we call that oxidized. So we call it reducing agent. So we could talk about combination reaction by redox reactions. In the previous example, we talked about CH4 O2 to make CO2 and H2O. This is the combustion reaction. So as you see here, we are able to define combustion reaction, decomposition, single, double displacement, combination, everything by redox reaction. Next example, I'm going to work on this. Na plus HCl is going to make NaCl plus H2. If we are going to balance this reaction, so let me write 2, 2, 2. So this is example of single displacement reaction. Right now, I may ask you to pause the video and see what compound, what element based on these two. They are going to be oxidizing, reducing agents, reduced, oxidizing. First, we are going to work on oxidation number. Na, free element, 0. HCl, I know for hydrogen is 1 positive. For Cl, I need to calculate that. So let me write it here. HCl. Let me put mark here. 1 positive for hydrogen plus Cl is going to be 0. There is no charge. So Cl is 1 negative. So Cl is 1 negative. NaCl. Na group 1 in the compound. Look here, this is the ion. Na1 positive, Cl1 negative. This is the compound. When we have free element 0, Na in the compound is 1 positive. How about Cl? So let me calculate again. We know that, but let me calculate that. Na is 1 positive plus Cl is equal to be 0. So Cl is going to be 1 negative. And hydrogen is 0, free element. Please understand. When we say free element 0, if we talk about compounds or ions, it's totally different. I'm going to compare. Na is going to be changed from 0 to 1 positive. Na is going to have oxidation because oxidation number increases. Oxidation. If we have oxidation, we call that this one oxidized. Oxidized means reducing agent. So when we know that, so definitely this reactant must be participate in the reduction reaction. And we call that reduced. We call that oxidizing agent. Does it work or not? H, 1 positive, H 0. So H is going to be changed from 1 positive to 0. Decreasing in this reaction happen. Oxidation number decreases. We call that reduction. We call that reduction. So whenever we have reduction, reduced oxidizing agent. So there is no difference for Cl. As you see here, there is no difference for Cl. Cl1 negative, Cl1 negative. So it means at HCl, hydrogen is going to be changed. But in the reactant side, we have HCl. So we call that HCl is going to reduce. We talk about only compound, only reactant. We don't talk about single atom. So we talk about reactants. Na is oxidized, HCl is reduced. Na is reducing agent and HCl is oxidizing agent. So in the next level, we are going to work with more examples and we are going to talk about all types of reactions like this strategy. Thank you for watching this video and take care, guys. So let me keep all of them. And again, thank you for watching this video.